Okay, for sample problem number 2, we have a projectile fired with an initial velocity of 150 meters per second. So that is at A. So our initial velocity V sub A is equal to 150 meters per second off the roof of a building. So we need to get the range R. So the range is the total distance traveled of the projectile from its starting to its final position, where it strikes at the ground B. Okay. So in this equation, since the initial and the final position of the projectile is not in the same elevation, therefore we cannot use the formula nga katong range or equal to VO squared sine to theta over G. So we cannot use this one. So lahat itong gamiton katong lang components gyapon. Okay. So we have, so if you notice nga walay angle nga given but we have this one. So ako na lang isulat daan para mas dali. So if you have this triangle 3 4 5, then this is theta. Our cosine theta is equal to adjacent over hypotenuse 4 over 5. And then our sine theta is equal to opposite over hypotenuse, that is 3 over 5. So we need to solve for r. Therefore, delete na to magamit si horizontal component ng formula because it will have too many unknowns. So we use first the y or the vertical components. So we have the initial velocity. We can solve for the initial velocity of y. The vertical component of the initial velocity using this formula. We also have this one, the final position of the projectile from its initial position, which is equal to 150 meters, and since panaog man siya, that is equal to negative 150 meters. So we use the formula y is equal to the final position is equal to the initial position plus the initial velocity, the vertical component of the initial velocity, times the time minus 1/2 the gravitational acceleration times the square of the time. So we have here y, which is negative 150. Okay, panaog siya. Initial position sa vertical, that is 0. If this is our origin, again, if this is our origin. So I'm making this one as our origin. And then the initial velocity, or the vertical component of the initial velocity, we have 150 meters per second sine theta, which is 3 over 5. 3 over 5 times the time minus the half of the gravity, 9.81 meters per second squared, times the time, the square of the time. So finally, simplifying the equation, the problem, we have negative 150 is equal to 150 times 3 divided by 5, that is 90 t minus 4.905 t squared. So here we can rewrite this one. This is a quadratic equation. 4.905 t squared minus 90t minus 150 is equal to 0. Using the quadratic formula, t is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So ang ato ang a is this one, kaning abay ni t squared 4.905. Atong b is equal to negative 90, and then our c is negative 150. Substituting it in this equation, we have two roots since this is quadratic equation. So we try first with the plus. This is equal to negative b. So negative of a negative, that is positive 90 plus or minus square root of b squared, square of 90, negative 90. So square of negative 90, that is 8,100, a positive, minus 4 times a, which is an times a 4.905, then c negative 150. all over 2 times a 4.905. So solving this one, we can have two roots. Our first one is 90 plus square root of 8100 minus 4 times 4.905 times negative 150 all over 9.81. See 2 times 4.905. We have the time as 90. First root is 19.8864 seconds. Our second root, we use the minus to subtract, which is negative 1.54. So we don't have a negative time, therefore we use this one, 19.8864 seconds. So we already have the time, the total time traveled from point A to point B. So we can now use the horizontal component for equation for the projectile. So x equals to x naught plus voxt. So this is our r. So if ato ni gamiton earlier, natay do ka anon, we don't know the range and we don't know the time. Pero ato magigamit si y, so we already know this one, the position, final position, the initial position. We can solve for the VAY, and then ang only unknown nato is ang t, which is the time. So atong r, which is kani si x, to initial position along the horizontal component, that is a 0, plus the initial velocity along the horizontal component, 150 cosine theta. So atong cosine theta is 4 over 5 times 4 over 5 times the time, which is equal to 19.8864. And then atong r is just equal to 150 times 4 divided by 5 times 19.8864. This one, 2,386.37 meters.